Okay, so what I'm going to do in this video is show you how to simplify by factorization. So this is when we've got something like this. Let's say, let's call this A, 4m plus 20 divided by 4m. So let's just start with something like that. Now, what we would not want to do here is cancel the 4m's here. We can't do that because we've got a polynomial, in fact a binomial, so two parts, but a polynomial expression here, and you simply can't do that. And in the second part of the video I'll explain why you can't just cross these off and cancel the 4m's. What you have to do, in fact, is divide through both terms, so it's a form of distribution. But the technique that I'm going to show you here is to always factorize first, so you can see what you're dealing with. Now, the denominator is already factorized, so you've got a 4 times an m, so there's nothing to do there. But the numerator has a common factor in both these terms of 4. So if we write 4 and then open brackets m plus 5, then that's the factorized form of the numerator here. So what that means is we can now do some cancelling because we've got 4 in the numerator and 4 in the denominator. Both of these are products, so we can just cancel. So we divide the top by 4, so 4 divided by 4 is 1, and the denominator, we must do whatever we do to the numerator, we must also do to the denominator to keep the balance. So divide by 4, so we've got 1 again. We don't have to write these ones, but just to remind us that we don't have a 0 in the bottom here when we cancel, we have a 1. So it's 1 times m now, or just m. So let's write the answer out. Our answer now is m plus 5, and we divide by m, so m plus 5 over m. So that's called simplification, or simplifying by factorization, and it's when we start with an expression that can be simplified, and it's simplified simply by factorizing either the top or the top and the bottom, or just the bottom, seeing what can be cancelled, dividing through, and then arriving at the simpler expression. Okay, so let's try another one. This time I'm going to look at, let's have an expression where this time the common factor is the variable, not just the number. So 17p minus, let's say, pq divided by p. So again, factorize where possible, then you can see what's going on. So the common factor in these two terms in the numerator is p. So pull out the p, then in the brackets 17 minus q, check, let's put a little tail on there, check that this would multiply out to get the expression that we had originally. So we got 17p minus pq, and then p still in the denominator. So now we can cancel the p's, we don't have to put 1 this time, and get the answer 17 minus q. Okay, so this is the general idea. Let's do another one. This time what I want to do is, let's use a quadratic expression. So x squared plus x minus 6, for example, and in the denominator simply x minus 2. Now if you're not sure about factorizing quadratics, I'm only going to use very simple quadratics in this tutorial, but if you're not sure about how to factorize a quadratic, don't sit there being confused about how we're doing this as if it's some sort of magic. Go to the go to the video where we show how to factorize all quadratics. But in this case, we can do this mentally, so I'm not even going to do any working out here. The -6 here is what I'm looking at, so it's going to be factors of 2 and 3 will give us the 6 here. So if I put my brackets in first like that, put my x in the first terms here, and then we've got, well, it's got to be 2 and 3. And it's going to be, we need a positive in the middle, so it's going to be +3 minus 2. So x minus 2, x plus 3. Okay, and x minus 2. Now you can see now why I've done this. If I put brackets around this x minus 2, sorry, that's not very neat. Let's just neaten that up a little bit. There we go. Then you can see we've now got 2 factors here in the numerator, and one of those is exactly the same as the binomial we've got in the denominator. So great, we can divide the numerator and the denominator by x minus 2, which means we can cancel. So we can just draw a line through that and draw a line through that. We've now got 1 in the denominator and just x plus 3 in the numerator. So that gives us our simplified expression as x plus 3. Okay, let's have another go. This time, let's do something a bit unusual here. What you might be given, I suppose, this would be very advanced, but let's just show how it would be done. You might be given something, let's use a z just to be a bit more interesting. You might get something that's a bit more disguised. So we've got z to the power 4 minus 3z squared plus 2. Now that is in fact a quadratic, and you'll see why in a moment. So if somebody says to you quadratics always have x squared, well, no, not always, but this nevertheless is a quadratic form. In the denominator here we're going to have z squared minus 1, and to show that this is a quadratic I'm going to use substitution. So let's just change the colour of the pen to do that. If you're not sure of this technique, again, go and look at another video, but what I've got here is z squared appearing everywhere, and certainly to show that this is a quadratic, all I need to do is substitute, so z squared here equaling, let's say, let's call it u. Okay, so every time there's a z square I'm going to replace with a u now, and it works like this. I rewrite the expression, so instead of z to the power 4, well, that's going to be u squared, because z squared squared will give me z to the 4, so u squared is going to be my first term here, minus 3u, the z squared gets replaced by the u there, plus 2, and in the denominator I've got u minus 1. Now you can see very clearly we've got a quadratic here, nice simple quadratic as well. We're going to open brackets u, so it's going to be 1 and 2, and it's going to be minus 1 and u minus 2, so just factorizing it mentally there, and u minus 1 in the denominator. Now there we've got a numerator and a denominator where we can cancel, so u minus 1 is common to both the numerator and the denominator, so we end up with u minus 2. What's that going to do with this? Well, we now substitute back, so if I change colour, so instead of u minus 2, instead of u I've got z squared, so I rewrite this, instead of u I've got z squared, like that, minus 2. So, really complicated looking top heavy fraction there, now simplified to z squared minus 2. Okay. Now, moving on to fractions that combine. This can be thought about as another way of simplifying fractions. So if we had 2 fractions, that, let's say, we want to add together. So let's choose something straightforward, something like 4x plus 12 plus another unit fraction, so 1 over 3x plus 9. Well, immediately again I want to factorize where I can, so 1 over 4 is common to both expressions, so both terms of this expression rather, so 4x plus 3, so 4x plus 12 becomes 4x plus 3, and then add 1 over 3x plus 3. So 3x plus 9 becomes 3x plus 3. Now I can see that I've got x plus 3 in both of the fractions, both of the denominators of the fraction. Now, how do we combine fractions? If you think back to algebra, ordinary numerical algebra, then of course we have to find a lowest common denominator in order to be able to add these fractions together. At the moment they're not common, so we have to multiply up. So it's in fact the lowest common multiple of these two expressions, and the lowest common multiple, or LCM, of these two expressions has to be 12, because 3 and 4 will go into 12, both go into 12, 12x plus 3. So I rewrite my denominator, combining now the fractions. I rewrite my denominator as 12x plus 3. And now I can add my fractions, but I have to remember to multiply by 3, because 3/12 will give me 1/4, which is what I had originally. So 3. So 1 times 3, 3, plus, and here I have to multiply by 4, because 4/12 is going to give me my 1/3. So 3 plus 4. Then if I add these together, I'll end up with my simplified expression, 7 over 12 times x plus 3. And I could multiply this out, but I think that's just going to make things a little bit more unwieldy, so I can leave it like this. This is my simplified version of these two fractions combined. Okay, let's think of something else. What if we had something just a little bit more complicated, but the same sort of idea? So let's have x minus 1 over x minus 3, but this time let's stick to adding. We'll add now 2 over, and this time we'll have a quadratic, so we'll have x squared minus x minus 6. So again, nice straightforward quadratic that should be easy to factorize. So again, factorizing this out, we have 1 over x minus 3 can't be factorized, so that's done. Here we've got 2 over x, well, it must be minus 3. Whoops, just put our brackets in like that. X plus 2. Let's just check. Minus 3 times 2 is going to give us our minus 6, and minus 3x plus 2x will give us our minus x term in the middle. So there we go. Let's just rewrite this a little so it's nice and clear. So we've got as our second fraction 2 over x minus 3 times x plus 2. Now we should be able to see that our lowest common multiple is going to be this term, x minus 3, x plus 2. So we can combine. Lowest common denominator is going to be x minus 3, x plus 2. Now looking at this fraction, in order to get it back to x minus 3, we have to multiply by x plus 2, because that would then cancel. So we say it's 1 times x minus 2, x plus 2, sorry. So 1 times x plus 2, so it's going to be x plus 2 in the numerator there. And we add, well, it's simply going to be this value here, the 2, because this is already the same denominator. So x plus 2 plus 2. And if we now combine these terms in the numerator, we end up with x plus 4 divided by x. Well, we might as well multiply this out, since that's what we had in the beginning. That's going to give us a nicer thing. So it's going to be the same as we had before, x squared minus x minus 6. So there we go. We've combined these two fractions. We've certainly simplified. We've got the same expression here, and when we've combined it, we've found that the numerator becomes x plus 4. So it's x plus 4 over x squared minus x minus 6. Let's do one final one. And this time, what I want to show you is how complex these things can be, but complexity is something, you know, that can be fun. So yeah, we're going to produce something here that's a little bit challenging, but hopefully it will all work out nice and straightforwardly. So I'm just going to throw in here all the quadratics that I can think of. Keep them nice and simple, but let's multiply them together this time. So let's have another very simple quadratic. X squared minus 7x plus 10 is one I know. And what else could we have? X squared plus 4x plus 3. So again, the method is to factorize out. Once we've factorized these expressions, we'll be able to see what we've got. We'll also be able to combine, in fact, because this times symbol can be dispensed with once we've got everything multiplying together. So let's do that. So we've got the difference of two squares here, and I know that because we've got no middle x term. We've got a quadratic here, but it's one of these unusual quadratics where it works out like this: x minus 3, x plus 3. And so that minus 3x plus 3x will mean the x term disappears, and the minus 3 times the 3 will give me that minus 9. Okay, so in the keeping going with the numerator, perhaps we've got this term here now. We've got x, well, we're looking at this 10 here, so it's got to be x minus 2 times x minus 5. Because if I multiply it out again just to check, minus 2 times minus 5 will give us our positive 10, and minus 2x minus 5x gives us our minus 7x in the middle. So that's the numerator dealt with. Let's now draw along our fraction bar like that. So what have we got here? We've got 20, so it must be 4 and 5 must be the factors of 20 that we're combining. The 4 and 5 will give us our minus 1x in the middle there, so it must be x plus 4 times x minus 5. And our final expression here, we've got x squared plus 4x plus 3, so it's going to be 1 and 3. So we've got x, and it's all positive, so it must be plus 1 plus 3. X plus 3. There we go. Wow. Okay, so we've got the product of 4 binomials in the numerator and 4 binomials in the denominator. But what's going to happen is we're going to be able to simplify this quite rapidly, because you can already see, I guess, that there are common terms. So some of these binomials are repeated in both the numerator and the denominator. So if we take this x minus 3, well, that's not repeated. But if we look at this x plus 3, well, that's here, but also here. So if I cancel now, so divide by x plus 3, divide by x plus 3, I will simply have now 3 binomials in the numerator and 3 binomials in the denominator. So I've just cut down the size of my problem. Okay, simplifying again, I'm looking for another one, and I can see that x minus 2 isn't repeated, but x minus 5 is. So I can divide top and bottom by x minus 5. X minus 5. And now I think I'm done. I've got x minus 3 times x minus 2, and in the denominator x plus 4 times x plus 1. So that's my answer. Get my blue ink back. And I'm going to multiply out as I go. So x times x is going to give me x squared. Minus 3x minus 2x gives me minus 5x. Minus 3 times minus 2 gives me plus 6. And that's my numerator multiplied out. My denominator is going to be x plus 4 times x plus 1. So x squared. And then I've got plus 4x plus x, so that's 5x, so plus 5x. And my 4 times my 1 is going to give me plus 4. So, there we go. Now, just to summarize then, we've got this as a, if we have this as a kind of general expression for the sort of things we've been dealing with, you can see very clearly how tempting it is if we've got the same coefficient of the y variable here, the same index here. It just looks like you ought to be able to cancel these two and just be left with a x to the power m. But no, you can't. Why not? Well, because what's going on is this ax to the power m, whatever this is, whatever it turns out this is added to the byn before we're dividing by byn. So the value is not as it appears here. It must be increased or decreased by ax to the power m, which is why you can't cancel. Now, this would apply, of course, as well if this was a negative, so either plus or minus. If it was multiplying, then yes, you could start sorting things out, because this then would be a scalar. It would be scaling this. But no, it's actually changing the value up or down, and so that's why you can't simply cancel these two expressions. Unless a equals b. Now, if a equals b, so let's just change this. Then this would be b x to the power m. Then you've got a common factor, and it's that we've been dealing with in this video. So now we can factorize. So we end up with b as the common factor times open brackets x to the power m minus y to the power n, close brackets. So now anything in the brackets, well, that's very different to what we've got down here. But here we've got b, let's just make this clear, b to the power yn, so we can again put this in brackets so we can see it very clearly. We can see that the b here is common to both the numerator and the denominator. So we can cancel the b, leaving us just with that expression there. Okay, let's erase that. Now, one final thing before we end the video, and that's well, let's re-look at a couple of the problems that we were working through in the first part of the video. So here we had 4m plus 20 over 4m, and we then did exactly this. We cancelled, we factorised, then we cancelled, and then we ended up with this simplified expression. Now, one thing I didn't mention is that we might want to summarize this result. And if we were to summarize it and want it to be completely correct, we would say 4m plus 20 over 4m not is equal to m plus 5 over m, but is identical to. Write this with a symbol that looks like an equal sign but has an extra line over the top there. So that means 4m plus 20 over 4m is identical to m plus 5 over m. And what we're saying here is there hasn't been any sort of great calculation here. It's just that whatever we have over this hand side, it's exactly the same. There's no difference. It's identical to this right hand side expression. Let's have a look at another one. So we've got 17p minus pq. Again, we would rewrite this if we wanted to make a statement. 17p minus pq over p is identical to 17 minus q. Okay, let's have a look at a couple more, I guess. So we'll just look at C and D. What did we have here then? We've got x squared plus x minus 6. Nice quadratic there, but it's divided by x minus 2. Well, we've worked out that that's identical to x plus 3. And here we had this extraordinary thing, z to the 4 minus 3z squared plus 2 over z squared minus 1. Not equal to, but identical to. It's an identity, identical to z squared minus 2.